lovely plants, how are you? I got some num num for you. Oh, what a beautiful day it is to not die. Oh, my plants, get your food. Get your food, I love you. No, I love you. No, I love you. I love you more. Oh, my precious plants. Oh, look at you. I'll get you thirsty, little rat. Thirsty rat. Thirsty rat. Thirsty rat.
Well, I'm the narrator.
What's he narrating?
Well, the ice cube.
What's Ice Cube? We're in the woods!
What ice cube? Well, actually, that one, actually.
Well, what's so interesting about an ice cube?
Not just any old ice cube. It's the Milky Way. Well, you can use it to represent the Milky Way in the universe of these woods, creating a fascinating but easy to follow thermodynamic system. In a thermodynamic system, a universe consisting of surroundings and systems and made up of quantities of matter, its pressure differences, density differences, and temperature differences all tend to equalize over time. Thus, the difference in temperature between the air and the ice cube begins to be equalized as portions of the heat energy from the warm surroundings become spread out to the cooler system of ice and water. Over time, the temperature of the ice cube and the temperature of the air become equal. The entropy of the air has decreased, and some of its energy has been dispersed into the ice, causing it to melt. However, the entropy of the system of ice has increased more than the entropy of the surrounding air has decreased. In an isolated system, such as the woods and ice taken together, the dispersal of energy from warmer to cooler always results in a net increase in entropy. Thus, when the universe of the woods and ice system has reached a temperature equilibrium, the entropy change from the initial state is at a maximum, and there's no more Milky Way. Of course, it will take the Milky Way a lot longer to melt than it takes an ice cube. In fact, it will be about 100 trillion years before there are any noticeable differences. In that time, all of the hydrogen in the universe will be depleted, meaning new stars can't be created. Everything goes downhill from there. The depletion of hydrogen marks the beginning of the degenerate age of the universe, and 900 trillion years after it starts, planets will be flung from their orbits. In another 9,000 trillion years, stars will be flung from their orbits as well, leaving the universe with mostly scattered stellar debris, and some supermassive black holes. All this happens less than halfway through the degenerate age. 1 million trillion years after there's nothing left but space dust, half of the protons in the universe decay. 10 billion trillion years after that, all the protons in the universe are gone, marking the end of baryonic matter and the degenerate age. It's a sad day indeed. The next age is called the black hole age, and for the next 10 billion trillion years, decaying black holes are all that remain in the universe. Whatever black holes that are left at this point spend the next trillion years decaying through a process known as Hawking radiation. At this point, all matter that used to make up the stars and galaxies has now degenerated into photons and leptons. This marks the beginning of the photon age, which goes on indefinitely. There's so little energy left at this point that it's impossible to predict what will happen.
So basically the universe is doomed.